Okay, so now that we understand overloading methods here, it's time to talk about another polymorphism concept called overriding methods. We go back to our dog here, our dog class. You notice our dog class has nothing. The body is empty, right? It all works out right now because we know we are extending or inheriting from our animal class. Obviously, when we create a class, our intention is to give it a few properties and behaviors of its own. Let's go ahead here and say, just give it one, say private. I'm going to say string, give it a name. And inside here, I'm going to go ahead and create a few behaviors. The first one is going to be public. Say void move. Okay. Let's say system out. Move, something like this. Okay, I'm gonna say move. Now I'm gonna save this. I'll go to our main entry point here. What I'm gonna do, let me go ahead and comment all of this out so that we don't have unnecessary prints out. Okay, so we still have our my dog here. So what I'm gonna do, I'm gonna say my dog dot, and I'm gonna say move. So if we save this, and you can imagine the results are going to be move, right? Because it's calling our move function. Okay, that's great. Now, the idea of overriding methods goes as follows. If we understand the concept of inheritance, we know that when we inherit from a superclass, in this case we are inheriting from our animal parent class here, which means we're getting all of these private, all of these instance variables, as well as all of the methods, okay, behaviors. We understand that, but then we realize that the whole idea of inheritance is that we inherit those properties, but we still have to be our own entity. So going back to the concept of a person, me as a person, I have inherited certain features or characteristics from my parents, but that does not mean that I am my parents. But all of the most important features, such as my build, my skin, my nose, and what makes me a person, as physically or biologically speaking, I inherit from my parents. But I have my own behaviors, right? And I may have some other characteristics that are simply my characteristics. So the same goes with our dog here. Although this dog here inherits from animal, this superclass, it needs to have or could have its own properties as well as its own behaviors. Behaviors that are original, that are very specific to the dog. For instance, the make sound, as you notice, the make sound is a very polymorphic behavior, meaning it can change depending on the circumstances, right? And an animal can say grr, sure, it can make all these different types of sounds. But when we're talking about a dog, now we're becoming more specific of what kind of an animal, because an animal is just a very abstract concept, right? I am an animal, you are an animal as human beings, but we are people, we are humans. So that's a specific type of an animal, right? So in this case here, we would want, for instance, to say that dogs make noise in a different way than any other animal, than a generic animal, right? Which means here we can go and say public void make sound like this. I'm going to say system that out, that print ln, and I'm going to say woof, like that. Now, if you notice here what's happening, I have this make sound. If you go back to our animal, there is the make sound function as well. Now, let's go ahead and run this. I'm going to change this to make sound. Let's see what's going to happen. So if you save and run, you notice now instead of going back to animal here and say grr, right, because this is the parent class, it knows to go and override, because now we're talking about a specific dog, right? We're talking about a dog which extends from parent animal, but a dog is not a generic animal, it's specific. Therefore, we are making sure that we override the make sound function from our parent class, animal in this case. And we can keep going. We can go ahead and even say public void again, make sound. We can go ahead and pass from the string. Let's see, go back to animal here. This was sound type. Let's pass the same thing so that I can show you here, right? We can do the same thing here. I'm just going to go ahead and pass the sound type variable or parent parameter. If I save this and go back to our main, and I call and I just pass here, for instance, another woof as such, and save and give it a run, you'll notice it will go ahead and call the another woof, which is specific to our dog animal. Okay, so we're able to make it so that our dog is indeed specific type of animal. Even though we extend or we inherit from our animal superclass, we are making sure that the make sound and the make sound, actually two of these makes overridden methods make sounds, that they are specific to our dog. So any other class that we may create, such as cat or cobra or person even, we can specify, we can get all of the features from our parent, but then inside of our own class, inside of our own entity, we can create different specific behaviors for ourselves. So you can see the flexibility now. We talked about the overloading methods, which is we make sure that all of the methods, behaviors with the same name, in this case functions that have the same name, we have to differentiate them by having different signatures or different parameters. As you can see here, the same name makes sound, but we just changed what we are passing as parameters to give us that flexibility. But now we've talked about overriding methods, which means now we are specifying, making sure that those methods are targeted to a specific object, even though we are inheriting from our parent object, and that our parent object or class has those behaviors. We're saying, nope, all I want actually is to be able to invoke my own behaviors as opposed to those behaviors of my parent. That is the second concept when we talk about polymorphism. Okay, so I'll see you next.